Hello, everyone. Welcome to Geology 1030 Natural Disasters at the Community College of Rhode Island. This is Dr. Rieger speaking. I'll be the instructor for this course. It is my pleasure to be your instructor, and I hope that you take away a lot of positive things from this course and that you find it interesting. This first lecture, in the course, we look at Chapter 1 of Abbott's book, Natural Disasters, and we look at natural disasters and the human population. So what we're going to do is we're going to first kind of define what a natural disaster is, and then look at trends in natural disasters, and look at those trends in the context of human population. And then also we're going to look at human population itself and look at what factors influence human population and what are projections for the population on Earth for the future. So this is a picture after the 2010 Haitian earthquake. We'll see that you see from this image that there is almost complete destruction. And this image shows that natural disasters and their impact on human population is not the same across the board. There are a lot of factors that play into how devastating a disaster is. And those are human factors, which we'll look at. So for example, this same size earthquake could strike in, say, California and be much less devastating. The reason being is that the infrastructure of California, being part of the United States and having much more resources to invest in infrastructure, is built to withstand the shaking that occurs during an earthquake. Where unfortunately in Haiti, a country with a developing economy, does not have the resources to invest in an infrastructure that can withstand an earthquake. So whenever the earthquake did occur, the infrastructure crumbled, thus exacerbating the impact of the earthquake. So we will see that there are several human factors that play into how significant the impact of natural disaster is on the regional human population. And it's not just the size of the event itself. Okay, so regarding natural disasters. So natural disaster is any natural phenomenon that has a negative impact on the human population. So it could be any size, very small. It could be a small isolated landslide just behind your house. Say if you live on a hillside and the slope gives way behind your house and it takes out, fills your first floor in your basement with mud, or even worse, maybe destroys your house. That is a natural event that had a negative impact on human population. That is a very small scale natural disaster. And obviously we know that natural disasters can be much larger scale, large earthquakes, hurricanes, and so forth. So there are natural disasters, and then there are what we call great natural disasters. So for example, the 2004 Indian Ocean tsunami, or the 2010 Haitian earthquake, which we just saw the photo of, those are examples of great natural disasters. So what's the difference between them? What is the difference between a natural disaster and a great natural disaster? Well, great natural disasters are those events that so overwhelm a region that they cannot handle the recovery, the rescue of the people, and the recovery and reconstruction on their own, and they require international assistance. So common threads of great natural disasters is that they commonly kill thousands of people, leave hundreds of thousands of people homeless, and they overwhelm the regional economy. So a given event, natural phenomenon could happen in one part of the world and be a great natural disaster, and that an event of the same characteristic, same type of event, same size, same magnitude, could occur in another part of the world and not be a great natural disaster. So, for example, um, hurricanes that more recently hit Texas and Louisiana, such as Hurricane Harvey, or I forget the one hit Louisiana, but two of them hit Louisiana this past summer. But those hurricanes that hit the Gulf Coast of the United States, they were not great natural disasters because the United States in itself was able to respond to those. But say those hurricanes, if they would have hit a smaller country with a developing economy, those countries may not have been able to completely handle the aftermath of those events themselves and would be deemed great natural disasters. So a great natural disaster, what makes a natural disaster great or not, is subjective, where it occurs. So here's a list of examples of great natural disasters. This is not a complete list. This is just an example, some examples. So the 2004 Indian Ocean earthquake and tsunami. It had 230,000 fatalities with 45,700 additional people missing. The 2008 Myanmar cyclone. A cyclone is another term for hurricane. 84,500 fatalities and almost 54,000 people missing. The 2008 Chinese earthquake, around 90,000 fatalities. The 2010 Haitian earthquake, 230 fatalities and 2 million homeless. The 2011 Tohoku earthquake and tsunami, it's 28,000 deaths. These are all examples of great natural disasters. Okay, natural disasters that required international assistance in the rescuing of people, cleaning up, and their reconstruction. So just looking at a period of time, this is data from 1950 to 2010, so we're looking at 60 years. 290 great natural disasters occurred during this time frame, with an upward trend, meaning there were more of the 290 great natural disasters occurred towards the end of this time period than the beginning. And this is partly due to an increase in human population. Remember, a natural disaster is a natural phenomenon that has a negative impact on human population. So we could have natural phenomena such as earthquakes, meteorite impacts, forest fires, floods that can occur in remote parts of the world and are not natural disasters because no one's living there to be negatively impacted. But if people were there, those would be considered natural disasters. So as the human population grows on Earth, there are more people to be impacted by natural phenomena and therefore more natural disasters. And so one of the causes for the general increase in natural disasters, and in this case, great natural disasters during this time frame, is the increase in human population. So during this 60-year time frame, the annual occurrence of great natural disasters occurs from zero. So in 1952, there was 0 to a max of 15 in 1993. And there was an average of 5 per year. And the disaster is, you see this is the number of great natural disasters plotted on the y-axis and the year plotted on the x-axis. And the type of disaster is color-coded. Okay, so red is earthquake, blue is storm, and so forth. So is there a correlation between the increasing number of natural disaster fatalities and the human population? Well, there seems to be. And as the population rises, it is reasonable to expect that the deaths due to natural disasters will also rise. But the relationship is not that simple. There are some nuances to it. And those are the social and political factors that I previously mentioned, the human factors. So looking at this table, we have the 40 deadliest natural disasters in a period of time ranging from 1970 to March of 2012. And we see that 26 of them occurred in Asia, Southeast Asia. So Asia, that includes everything from the Middle East, that's Iraq, Iran, Afghanistan, Pakistan, and then the eastern part of Russia, China, and then Southeast Asia includes the countries of Vietnam, Cambodia, Laos, and then Thailand, Malaysia, and South Asia includes India. So that's Asia and Southeast Asia. So 26 occurred in that region. 9 occurred in Latin America. That's Mexico, from Mexico down to basically Panama. And only 3 occurred in Western Europe, while none occurred in the US or Canada. So does that mean that there was just no large natural disasters that occurred in Western Europe, the US or Canada, and that for some reason, just most of the natural disasters occurred in Asia or Southeast Asia? Is that what this is telling us? Maybe it's telling us something else. So looking at this table, which disasters are the most frequent mega killers? So if you look at the third column from the left, that's the event. We see, hurricane, earthquake, 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 hurricane, hurricane, earthquake, and as we go down, you can see that, what are the most common events that kill a large number of people? Well, they are hurricanes and earthquakes, right? Every now and then you see a flood in there. A heat wave, interestingly, right here, August 2013, 2003. But most of them are earthquakes and hurricanes. And where do most fatalities occur? Well, that is in Asia and Southeast Asia. And that's where most fatalities occur. So most frequent mega killers have been earthquakes and hurricanes, as we've seen on the last table. And so most mega killer disasters occur in densely populated regions in Asia along the Indian Ocean. And so here we see maybe a reason for those mega killers, the most lethal disasters occurring in Southeast Asia, is because of the extremely high population density of these areas. So if you have a very large population density, then a natural disaster is going to result in a larger number of casualties and fatalities. And so the number of fatalities is proportional to the population density. So death totals are often related to economic and political factors as well. But this brings to our attention the first of the human factors that determine the deadliness or how lethal a natural disaster is, and that is the population density. Right. So Western Europe doesn't have the population density that South Asia and Southeast Asia has along the coast of the Indian Ocean. United States and Canada doesn't have that population density. Even Latin America doesn't have that population density. So that region has the largest population density of the planet and therefore has the largest number of deaths. It's not just the population density. That's one factor, but there's, as we said, economic and political factors as well. So as the global population of Earth increases, the number of deaths from natural disasters is expected to rise, as we've already said. From 1964 to 2004, 80% of deaths occurred in only 15 nations. Those included China, Bangladesh, and Indonesia. The other 15 countries, of these 15 countries, 87% were below the median democracy index and 73% were below median GDP. So to take a second here, what is democracy index? Well, the democracy index is a metric of a country's government, of how democratic it is. In other words, how much accountability the leaders of the government have to the people. So the United States ranks very high democracy index, being that we have a representative republic, that we elect our leaders on 2, 4, and 6-year terms. Right. So if our elected officials manage a situation poorly, if they don't handle the results of a natural disaster or prepping for a natural disaster adequately, they are accountable to us. We can vote them out and vote someone else in. Where if you live in an authoritarian dictatorship, you have no say, right? Your leaders can not do anything to prepare your country, your infrastructure for natural disaster, and they can do nothing to protect you from the consequences of that disaster, and you literally cannot do anything about it. So, as you might guess, the higher a nation is on the democracy index, the more likely the people in government are to respond to the needs of the people and do what needs to be done to protect them from natural disasters. And so it makes sense that 87% of these 15 countries where 80% of the deaths occur are below the median democracy index. So they're in the lower half. And so they have very little accountability, the governments of these countries, to the people that they govern. And then the 73% being below the median GDP. What is GDP? GDP is the gross domestic product of a nation. It's an economic metric. It is basically a nice, neat number to quantify the size of the economy of the country. And general rule of thumb, the larger the GDP of the country, the larger the economy. Right, so right now the United States, I believe, has the largest GDP, which is probably soon to be overtaken by China. But China and the United States by far have the largest GDP. So it's interesting that China is one of these countries, right, that has a large number of deaths, even though it currently has a high GDP, but that has not always been the case. Right, back in the 1960s, China was still a very agrarian country with a smaller GDP. Also, China does not rank high on the democracy index, being led up by the Communist Party. So exceptions to the GDP for most of this time frame, besides China as of late, are Iran and Venezuela. These countries have large GDPs. They have large GDPs due to the export of oil, but low democracy index. And also now, more recently, Venezuela has a very low GDP because of the price of oil decreasing. So Iran and Venezuela, for most of this time period, 1964 to 2004, had a very high GDP, but they're still ranked low on the democracy index. So what we see is a country may have a high GDP. It might have an economy that is generating a significant amount of money that it could use to invest in infrastructure to protect people from natural disasters. But if they don't have a government that's accountable to the people, then that money likely will not be invested that way. And we see that is the case in Iran and Venezuela, and in some case, China, right? So what we learn from this is democracy is more important than GDP. Your country could have a lot of money, but you have to have a government that's going to make the right decisions with that money to protect people from natural disasters to prevent these deaths. And the only incentive for government officials to make those decisions is by them being accountable to the people. right? So that's why democracy is important, is the accountability. So here we have the three factors. We have population density. Higher the population density, the more deaths. The GDP in general, the lower the GDP of the country, the more deaths. And then finally, with the democracy index, in general, the lower the democracy index, the more deaths. And that is the most important metric, is the democracy index. So the lower the democracy index, even with the low democracy index, a high GDP does not help decrease the number of deaths. There's a quote from a professor at Princeton University, Gregory Vandervink. It says, deaths from natural disasters can no longer be dismissed as random acts of nature. They are a direct and inevitable consequence of high-risk land use and failures of government to adapt or respond to such known risks. So what is he saying in this quote? Well, natural disasters, deaths due to natural disasters, used to be random acts of nature, right? Before we understood the science behind these events and how to, we'll learn this word in a little bit, how to mitigate or how to diminish the negative impact these events have on people. Before we knew that, it was random, right? We didn't know necessarily how to protect or how to forecast hurricane trajectories or how to build structures that won't collapse in an earthquake. So before that understanding, it was really random acts of nature, and we were, in some sense, defenseless against natural disasters. But that is no longer the case. The world has developed the technology and the understanding to help prevent many deaths due to natural disasters. So when deaths do occur from natural disasters today, especially deaths on large scale, you're not going to be able to prevent all deaths, but deaths on large scales, those are preventable. They are the result of either, the high risk land use that's, living on a coastline that's susceptible to hurricanes or tsunami, or failures of government to adapt and respond to such risks. So the government not taking proper actions to reduce the risk of these events. So they are preventable, right? They are no longer random acts of nature, they are preventable. And so whenever we have these great natural disasters, to a large extent, if these countries had ranked higher in the democracy index and they had more developed economies, more money to invest in infrastructure, they likely would not have these large mass casualty events as they currently do. So those are loss of human life during natural disasters. Now we're going to take a look at economic losses resulting from natural disasters. So the destruction and damage to structures, loss of productivity and wages due to people not being able to work, increase in economic losses over time is the result of increase in human population urbanization. So what this is basically saying is economic losses come in two types. They are the destruction of property and infrastructure, so buildings, factories, houses, and then infrastructure, roads, dams, bridges, telecommunication networks, public utilities. That's all economic losses. And then there's also the loss of productivity and wages. So after a natural disaster, people cannot work, they can't go to work, they cannot be productive. And so that's all lost money. It's an economic loss. And over time, the economic losses due to natural disasters have increased, and this is the result of human population switching from an agrarian economy to an urbanized industrial economy, where much more of our economic output is centralized in urban centers. And so whenever natural disasters impact these urban centers, it's a much larger impact on the economy because in a sense, the economy is centralized to these urban centers. The economy is larger too. So of a larger economy, whenever a natural disaster occurs, it's going to be a bigger hit. So the most expensive events that occur are caused by storms, and they occur in the United States, Europe, and Japan. And sometimes it can take years for the total dollar losses to be known. And so economic destruction due to the result due to the destruction of infrastructure includes the disabling of bridges, buildings, roads, power generation and transmission grids, natural gas, water, all the things that are required for society to operate, for commerce to operate. So when these are destroyed or disabled, the economy takes a hit. So in this table, this is not the 40 most deadly natural disasters, but the 40 most expensive or costly natural disasters. So we see the loss in millions of 2011 US dollars. So by 2011 means these figures are adjusted for inflation so that they're all in terms of 2011 dollars. This is the fatalities, start date, the event, this is the country. All right, so 39 of the 40 most costly insurance disasters were natural disasters. There was one that was not a natural disaster. Where is it? Right here, right here. It was, get my pen. It was the terrorist attack on September 11th, which some of you may remember, some of you may not. But the 39 others were all natural disasters. Notice where they occurred. So we look in the far right column, we say USA, Japan, a long string are USAs, Thailand, New Zealand, USA, Japan, USA, Chile, Europe, USA, Europe, Japan, USA, and so forth. And so we see that most of the most costly natural disasters occur in the United States, Japan, and Europe. So here they're switched, right? The United States and Europe had the fewest deaths due to natural disasters, right? But they at the same time have the most costliest natural disasters, have largest economic impact. And so the deadliest and the most expensive do not always coincide, because often a natural disaster is expensive if it hits a country with a developed economy. And most countries with a developed economy rank high on democracy index and have a large GDP. So therefore they have money and the government to invest that money in infrastructure that will protect the people. So therefore we don't have a large number of deaths, but we do have a large amount of economic losses. So in the end, it's better to have the economic losses than the human fatalities, right? The optimal situation is to have the money and have the government to provide the infrastructure and the investments needed to protect the human population from these natural disasters. Because these events are not going to stop occurring. They're natural processes that are going to occur. And so in order to reduce the number of deaths, we need the proper investments. So where do we invest and how much do we invest and what do we do to protect us against natural disasters? Well, the first step is to identify a natural hazard. So a natural hazard exists anywhere where there is the potential for a natural disaster to occur. So therefore, there is risk. Where the risk is non-zero, it is a hazard. And hazards exist even where the disasters are infrequent, because infrequent does not mean that they never happen. So people tend to think, oh, if the risk is small, then there is no risk. Like if you said there is a 10% risk that you could fall down the stairs and break your leg this morning when you get out of bed, think like, oh, that's not a high risk. Like I'm gonna be okay. I'm gonna walk down the stairs. But 10% is 1 out of 10, right? It's actually not that small of a risk. 1 out of 10 times, that means over the course of 10 days, you are very likely to fall down those stairs, right? So even small risks can be appreciable hazards over time. And we'll see that relationship between time and risk. So the infrequency of a disasters that have low probabilities or low risks are often more destructive. Why? Because that false sense of security that I was just talking about, how I'm not going to fall down the stairs. It's only a 10% chance. I don't need to worry about that, right? Oh, that volcano, it hasn't erupted in 400 years. What's the chance it's going to erupt in the next 20 years? So I don't have to worry about that. And so natural hazards, they're very hard to evaluate the site risk. And it might seem easy sometimes, looking at a natural disaster with hindsight, be like, oh, people should have did this, people should have did that. But it is really hard to evaluate the risk of a natural hazard before it happens. And it's hard to convince populations to act on those risks too, as we'll see. So here's a case history of a natural hazard. So Popocatépetl, if I didn't butcher that. Actually, it's a volcano. It goes by the shorter name of Popo. It's a volcano in Mexico. It lies between Mexico City and the Puebla. This is his nickname, Popo. It has experienced eruptions in the years 822, 1519, and it began erupting again in 1994. This volcano has been devastating in the past, in the distant past. But there are currently millions of people living in the danger zone, and currently 100,000 people are living at the base. So let me ask, why would so many people be living in the danger zone, and not even the danger zone, living at the base of an active volcano? Well, it's many reasons, right? One reason is the volcanic material breaks down into very fertile soil for farming, so it's attractive for those reasons. And also people's families. They live there several generations, and so they have roots, so they don't want to leave, even though they are in harm's way. And for many of these families, several generations have passed, and the volcano has not had any negative impacts on them whatsoever. And so the danger, the threat that the volcano poses is diminished in their psyche. Now, just as a person that lives in, say, for example, San Francisco, California, wakes up every day not being paranoid and anxious about a large earthquake occurring, even though it could occur. Every single day it could occur. But if you lived your life that way, you would be miserable, right? And so ask yourself, should people not live in this area just because there's a chance that 200 years from now, a large volcanic eruption could occur and their great grandchildren could be negatively impacted? Or 20 years from now, there could be a large eruption and them and their children could be negatively impacted, or tomorrow. So it's hard to know the time frame. So it's hard to assess, well, should people move here? Should they move out? You know, it's hard to assess what to do. So should people move out of harm's way, out of these natural hazards? Well, the question is when will it occur? If we knew that an event was going to occur in the immediate future, then it's much easier to convince people to move. But if it's unknown when an event will occur, it's much harder. Because people would have to leave their homes for undetermined length of time, if not indefinitely, in some situations. So it's very easy to identify hazards, but it's not easy to decide how to deal with them. Other hazards are faced with the same type of questions, like I said, you know, San Francisco, California, right? That is a earthquake hazard. And so should people just not live in San Francisco because there is a risk of a large earthquake occurring? Well, obviously, many people have decided to live in San Francisco, just like many people have decided to live within the danger zone of Popo. And so people live within these natural hazards, but what they do is they employ what is known as mitigation. So mitigation is the most common approach to natural hazards. And mitigation is the process where we make plans and take actions to, in the best case scenario, eliminate, but usually it's just, we can never completely eliminate it. We take these actions to reduce the threat of future death and destruction when natural hazards suddenly become great threats. All right, so mitigation is basically, okay, we're going to live in this hazard, but what can we do? What plans can we make? What actions can we take that if and when this hazard becomes a threat, the event actually occurs, we can minimize, if not eliminate, the negative impact it has on the human population. So there's two types of mitigation. There's mitigation prior to the event. That's engineering physical, social, and political plans and actions to reduce death and destruction of natural hazard, building buildings to not collapse in an earthquake, right? Social and political plans, having evacuation routes, and so forth. Then there's mitigation after event. That's rebuilding and re-inhabiting the same site. So mitigation after event could be we rebuild differently, right? We learn from what happened and we rebuild differently. Or a form of mitigation would be to even reassess whether to re-inhabit the region at all. So now we're going to look at the relationship between the magnitude, which is the size or the scale of the event, and the frequency, which is how often it occurs in a given time period. So there is an inverse correlation between frequency and magnitude of a process. So frequent occurrences, frequent events, are low in magnitude or low in scale, while rare occurrences, rare events, are high in magnitude. Another way of saying that is small events occur very frequently. Little tiny earthquakes, small storms, they occur very frequently. Where large events, very, very significant magnitude, 8, 9.0 earthquakes, very large, category 5 hurricanes or EF5 tornadoes, they occur very infrequently. So small scale activity is common, while big scale events are rare. And the larger the event, the larger the return time. The return time or return period, also known as a recurrence interval, that's the average amount of time in years between an event occurring. So if you ever heard the term 100 years flood, that's a flood of the size that has the probability of occurring any 1 year of 0.0 of 1. So it's a 1% chance of it occurring in any year. So after 100 years, there is a really good chance that that event occurred because there's 1% chance in a year. And so its frequency would be roughly once every 100 years, or the recurrence interval would be 100 years. So different size floods have different probabilities, and therefore different frequencies and different recurrence intervals or return times. So this table has the probability estimates of various size. The size is indicated by the human impact, the number of fatalities. We have a 10 fatality event and 1,000 fatality events. And so we see here, this is the likeliness of 10 fatality events. So during different time intervals, 1 year, 10 years, 20 years. So the likeliness of an earthquake that kills 10 people is 11% every year. So there's an 11% chance that there's going to be an earthquake that kills 10 people every single year. So during 10 years, there's a 67% chance there will be one earthquake that kills at least 10 people. And during a 20-year interval, there's an 89% chance there's going to be an earthquake that kills at least 10 people. So see, the longer the time interval, the higher the probability that an event will occur, right? Because you have more time, it's obviously more likely that it'll occur. There's a 39% chance that a hurricane will occur that will kill at least 10 people in a 1-year time period, 86% chance for flood, 96% chance for tornado. So in any given year, which event is most likely to basically kill people? Well, it is a tornado. There's a 96% chance that there will be a tornado in any given year that will kill at least 10 people. Well, if you look at the likelihood of 1,000, fatalities, there is only a 1% chance that there's going to be an earthquake that big in any given year. 6% chance of a hurricane, 0.4% chance of a flood, and 0.6% chance of a hurricane. So if you're saying, well, any given year, what is more likely to kill a large number of people, at least 1,000 people? Well, it's an earthquake. That's a singular event. Okay, so, but looking at this table, which events are the most deadly? Which type of natural disaster kills the most people? Of those listed on this table, those tornadoes. Why do you say that? Well, there's a 90% chance that there's going to be a tornado every year that kills at least 10 people. All right, so every year it's likely there's going to be a tornado that kills at least 10 people. So in 10 years, it's likely that 100 people will have died from tornadoes. Well, there will be less than floods, hurricanes, and earthquakes. In any given year, it's unlikely that there's going to be any event that kills 1,000 people. So really, these small events, are killing most of the people. We hear about the large killer events that kill thousands of people, but they're actually fairly infrequent, right? There's only a 25% chance, a 1 in 4 chance that there's going to be an earthquake that large in 20 years. Right? So whenever we want to protect people from natural disasters, save lives, we often think about the big mega killers, but the events that kill a large number of people in the singular event. But the most people are killed by the small, frequent, the many small events, the small storms, the small tornadoes, floods. And so protecting people against those is actually more important, or can save more lives. So events such as earthquakes, volcanic eruptions, landslides, storms, floods, fires, meteorite impacts, and extinctions, they occur every day and are common, but their magnitudes vary drastically over space and time. On a yearly basis, most low fatality events are due to floods and tornadoes, and return times are brief, less than 1 year. High fatality events are dominantly hurricanes and earthquakes, and the return times are much longer. But it's these floods and tornadoes that occur very frequently and kill a small number of people that adds up, and they end up being responsible for the most deaths, right? But if you look at death by any one particular event, then hurricanes and earthquakes are the most deadly events, singular events. So example, I already alluded to this one, the big one in San Francisco. Being along the San Andreas Fault, San Francisco experiences many earthquakes, as many of us know. Many small earthquakes occur frequently along this fault. However, several large earthquakes have struck San Francisco in the past, namely 1906, 1989. The probability of a large earthquake occurring any given year is very small. However, the probability of a large one occurring over the next 100 years is significantly larger. So in other words, say, oh, what are the chances of there being a large earthquake in San Francisco this year? They are pretty small, right? And because they're pretty small, you might not need to really worry about it. Doesn't mean it can't happen, it's pretty small. But if you say, well, what is the probability, what is the chance that a large earthquake is going to happen in San Francisco over the next 20 years? Well, that's much higher, right? It's much more likely that there's going to be a large earthquake in San Francisco over the next 20 years. So with that in mind, it makes sense to build our buildings in San Francisco to withstand earthquakes, to build our water lines, our gas lines, our electrical grids to withstand earthquakes, because they are going to be here 20, 30, 40, 50 years from now. And it's very likely that they are going to experience an earthquake. If we're building infrastructure that's only going to last 1 year, then yes, that infrastructure could very well might not have to face the test of an earthquake, right? But if we're building something that's going to be there long term, that significantly increases the probability that it'll be impacted by a large earthquake. So now we're going to kind of take a little shift to human population. So we have a quick overview. I'm going to talk about projections. So, because we talked about how the natural disaster deaths are partly influenced by the human population, and so if we want to make any kind of projections about natural disaster deaths in the future, the human population in the future is relevant. So it's difficult to assess early human population growth. The human species began, okay, so it begins in quotes, because it's kind of loaded. So the human species, which is it first appears in the fossil record approximately 160,000 years ago with a few thousand people. The human population has grown to over 7.3 billion people in 2016, and then now it's at 7.8 billion. So the growth rate of population on this planet is exponential. And I don't know if you are familiar with exponential, but exponential means that the more people there are, the faster the population grows, which makes sense, right? So the population growth just keeps accelerating and accelerating. So in the last 10,000 years of human history, and so there's relatively flat population curve until about 8,000 years ago. What happened 8,000 years ago? Well, agriculture was established. We had the domestication of animals, and humans transitioned from being a nomadic hunter-gatherers to creating stationary, societies, civilization. And so if you're growing your own food and livestock, you now have control over your food source. You're not relying on nature for your food source as a hunter and gatherer. And because you have control in your food source, that adds a lot more stability to your life. And as a result, the growth rate increased. The human population growth rate increased to about 0.036% per year. Still very modest, very modest. Because you think, now we just have a stable, relatively stable food supply, but we still have all the diseases, all the illnesses that we have no idea how to cure. We don't even know what's causing them. We still are eating by wild animals every now and then. Natural disasters occur for we don't know why, and we don't know when, where, why they're occurring, and they're killing people. So we still know so little about the world around us. All we have is a stable food source. So still a lot of people dying, and our population growth is relatively stable, but it just ticks up a little bit. By 2,000 years ago, population is around 200 million people. Now, by this time, there's better shelter, food, water supply, and so all those conditions yield a faster population growth. At this point, the growth rate was about 0.056% per year. By 1750, the population was 800 million people. Isn't that weird? Like 800 million people on the planet. That is remarkably small compared to now. It's just hard to fathom that less than 300 years ago, the population was 800 million people, and that we added 7 billion since then. By 1750, as we said, there's about 800 million people. We discover public health principles, causes and diseases, causes of disease are recognized. So people, now we have, adequate shelter, we have stable food, we have some technological advances, 1750s Industrial Revolution, and now we're starting to understand what makes us sick and what kills us. We have germ theory. And so now people are dying less often than they used to. So what's happened is the birth rates are still very high. So people are still having a lot of babies, but the death rates are dropping. And whenever the birth rate does not equal the death rate, then we have changes in global population. So why global population was relatively stable for most of human history was because the death rate was approximately equal to the birth rate. And we have population growth whenever the death rate is slightly lower than the birth rate, right? People are being born faster than they're dying, so the population slowly grows. Right, but as we have increased the life expectancy of people live longer, the death rate decreases, while the birth rate remains the same, the population begins to grow rapidly. By 1810, 1 billion people. 1925, 2 billion. 3 billion in 1960. 4 billion in 1975. 5 billion in 1987. 6 billion in 1999. In 2011, the population passed 7 billion, and currently the population is 7.8 billion people. Now, the thing about it is, I mean, me personally, I was born in 1986, so roughly 1987. There was 5 billion people on the planet. In the time that I've been alive, 2.8 billion people have been added to the population. And that's just remarkable, right? If you think about a billion. And in 200 years, from 1810 to now, approximately 200 years, there has been 6.8 billion people doubled. The population has almost increased by a factor of 8 in 200 years. a factor of 8 in 200 years. So as I said, presently the population is over 7.8 billion. And with that rate, we have currently a doubling time of 58 years. What is a doubling time? It's the amount of years required to double the population. So that means in 58 years, if the population continues to grow at the current rate, we'll be at, well, 7.8 plus 7.8, we have 15.6 billion. So that sounds like a lot of people. That is a lot of people, all right? It doesn't necessarily mean we will get there. That's just at our current population growth rate. So remember, as I said, the growth rate is equal to the fertility rate, which is the birth rate, the rate at which how many people are born, minus the mortality rate, which is the death rate. And if the fertility rate exceeds the mortality rate, then the population growth is positive. If the fertility rate is less than the mortality rate, then the population growth is negative. For example, there are several nations in Northern Europe, Norway, Sweden, so forth, that actually have negative population growth rates. Why is that? Because each year, more people die in those countries than are born. So their population is decreasing over time. If a country has, this is excluding immigration. If you don't include immigration, in general, if a country has more births per year than deaths, then it has a positive population growth, and its population will increase over time. So obviously the Earth has a positive growth rate. So there are more births per year than there are deaths per year. And the human population grows about 80 million people per year, which is roughly the population of Germany. And so looking at the future world population, we have to look at it in the context of what we call demographic transition theory. And so we know that mortality and fertility rates, they decline from high to low levels because of economic and social development. What does that mean? So economic and social development, as we have better science, technology, social systems to support people, they live longer, right? Your death rates decrease, mortality rates decrease. Also, if there's more economic opportunities, say for women, and for and we're less agrarian society, then there are fewer births. Another reason there's fewer births is because we have the science and technology to make sure that more of the births, more babies survive to adulthood. Or you have to remember that, you know, even 200 years ago, you know, families could have 6 or 7 children, and you know, and a number of those children wouldn't be uncommon for them to die, right? You have maybe 1, 2, or 3 of those children die. So you have a large number of children because you know some of them are not going to make it to adulthood because of the times, the lack of understanding of you know, basically our medical understanding. And so we also don't need the number of people as we used to. So 200 years ago, if you're a family and your economic well-being is based off of you working your farm and producing, you know, crops or livestock, then the most important asset you have is labor. And the best kind of labor is free labor, and free labor comes from your children, right? You have children to work your farm, and everyone works the farm and produces for the family. So it made economic sense to have large families. But as our society urbanized and as our economy is not just our country, but the world switched from an agrarian, an agricultural society to an industrial society, where we produce things in factories and mills. And we're able to, produce much more food with less people with the equipment and so forth. Then we don't need as many people, right? The machines and our technology help magnify the productivity of a person. So there's no need to have 5 children. And also, another factor is, you look at families 200 years ago, there is no such thing as Social Security. There is no such thing as social programs to help people in their older age. So your retirement plan is literally your children. And so the more children you have, the more likely it is that you will have support in your older age. Right? Or if someone in today's age doesn't have any children, they don't worry about, oh, who's going to take care of me whenever I'm older. We know that we have the infrastructure for that. We have nursing homes, we have, assisted living homes, we have people and infrastructure to take care of us as we age, but that was not the case then. So you can see all the incentives for those high birth rates in the past. The one was the high death rate, but also it was the economics of it, right? Where now the economics of it are not there, right? And we have lower death rates. So as a result, population growth rates are dropping from 1.8 in 1990, 1.8% in 1990 to 1.2% in 2010. And as I said, this is due to urbanization and increased opportunities for women. So more women in the workforce, the less children they have. But even though the population growth is decreasing, the population explosion continues. From 1950 to 2000, population grew from 2.5 to 6 billion. Current growth rate is 1.2% per year. It means population is nearly 9.5 billion in 2050. So let's consider the number of births per woman predicted to predict the 2,150 population in the future, year 2150. Okay, so if there's an average of 1.6 children per woman, we'll have a population of 3.6 billion. So that's actually a negative population growth. If we have an average of 2 children per woman, we'll have a positive population growth to 10.8 billion. And if we have an average of 2.6 children per woman, which is the current global average, we'll have 27 billion in the year 2150. So you can see what difference a small change makes. Because if every woman has, I know you can't have 0.6 of a child, but it's on average. If on average every woman has only 1.6 children, then our population will actually decrease. On average, if every woman has 2 children, the population will moderately increase. And on average, if every woman has 2.6 children, then which is the current average, then our population will be 27 billion in a little more than 100 years, 130 years. So what geographic regions are projected to see largest population growth? And are these regions exposed to natural hazards? What implication does it have for future? What implications does the future population model have on natural disasters? So this is in 1950, the population is 2.56 billion. In 2050, the estimated population, projected population will be 9.62 billion. In 2002, the population was 6.22 billion. And this is the size, the width of these sections represents the population. So we have China, India, the rest of Asia, Eastern Europe, Japan, Western Europe, and North America together, Latin America, North Africa, and Near East, and then Sub-Saharan Africa. As you can see, Asia constituted about half of the total population in 1950. So, right, it's about half. Half of the population is Asia, half the population, excluding Japan, half the other half was in Europe, North America, Latin America, and Africa. You go to 2002, now we're skewed. More than half of the population is in Asia, and less than half is outside of Asia. And if we project, look in the projections in 2050, we see that the population growth is expected to be most substantial in Asia, and we still have more than half of the population in Asia. Well, we know that Asia is a place where we already have large population densities, but we have countries with relatively rank low in our democracy index and have developing economies and have small GDPs. And so we know that these countries experience a large death toll whenever natural disasters occur. So the fact that the population growth is expected to be largest in these countries suggests that we can likely expect deaths due to natural disasters to only increase and actually increase at a faster rate. But this doesn't mean that the human population is just going to spiral out of control and there'll be more and more people. There is, as I mentioned, this demographic transition theory that the Earth is going through right now. So before the transition, there was high death rates. Those are offset by high birth rates to maintain the population. So this is, 8,000 years ago, right? We have a large number of deaths per year. So, well, to maintain the population, we have to have a large number of births per year. So this is before the transition. Now, during the transition, as we develop, agriculture, technology, medicine, the death rates begin to decrease. Okay, but the birth rates still remain high. So as an example, you have explosive population growth. But slowly the birth rates do decrease because the economics and the need for such a large birth rate are no longer there. But people's behavior is slow to change, right? Most people, that they come from a large family, they have 5 or 6 brothers and sisters, then they often want a large family of their own because that's what they know. I mean, that's okay. I mean, that's just, human nature. And so if people come from small families, then they're maybe more likely to have a small family. But over time, the size of families has been decreasing because, well, one reason is it's becoming more and more expensive to have children, at least in this country. And we don't need to have as many children because more of our children survive to adulthood, and the economics of having large families aren't there. So as the birth rates drop, the population growth begins to decrease because the birth rates are not as different from the death rates. And then finally, whenever the birth rates match to death rates, then the population stabilizes once again. Then it'll grow much more slowly. So the interesting thing for this graph is in each of these phases of the transition, early, very early, late, and after the transition has occurred, it has countries that are currently in that, have birth and death rates that are in that phase. So Uganda, Afghanistan, Nigeria, they have very high death rates and very high birth rates. And so their population is relatively stable. Their population is not growing. I mean, it's growing, but it's not exploding because you see they do have a little bit higher birth rates than death rates. Countries like Iraq, Guatemala, and Ghana, they're in this early phase. They have birth rates that are much higher than their death rate, so they're having significant population growth. In Gabon, India, Malaysia, they're in the late phase. Their birth rates are starting to decline, and so their population growth is still very large, but it's starting to wane. And after China, Japan, Germany, the birth rates are starting to match the death rates, and so the population is beginning to stabilize. I know the 2020 census from China that came out, they reported the slowest population growth rate that the country has ever measured since it has been collecting census data. So it shows that the population of China is growing slower and slower as the birth rates continue to fall. And there was a long time where they had the one-child policy in China to help curb their exploding population growth. So finally, we'll talk about carrying capacity, because carrying capacity relates both the population and natural disasters together in, well, not, I should say natural disasters. Carrying capacity is this concept that this kind of shows us how vulnerable a population is to disaster. So the idea of carrying capacity is that any environment is able to support a certain number of organisms, right? Because all organisms need food, shelter, all the corporal needs. And an environment only has finite resources. You can only grow so many crops. You can only have so many certain plants or so much water. So there's a finite amount of resources. Ultimately, planet Earth is the environment for the whole human population, and Earth only has a finite amount of non-renewable resources. And it can, with current technology, only produce a finite amount of food, for example. So the carrying capacity of any region or the globe is basically the population that can be supported with the current resources. And what happens if the carrying capacity of a region is suddenly decreased? That means that the region can no longer support the population, the size that is currently living there. So what happens is, well, unfortunately, there are a large number of deaths until the population decreases to what the new carrying capacity is. So an example of this is the potato famine in Ireland in the 1840s. This event is one of the reasons why many Americans of Irish descent are in this country. The potato was introduced to Ireland in the 1500s and it led to a population increase. I forget what it was. If it was a potato, milk, and bread, with those foods, you got all the required nutrients. But anyways, the population, the potato did very well in Ireland, and the cultivation of potatoes in Ireland led to an abundant food source, which allowed for the population to increase above what the population was prior to the introduction of the potato. But then the potatoes in Ireland got a disease, a blight, in the mid-1840s that led to them not being able to produce as many potatoes. So as a result, there was malnourishment and people were going hungry and starving to death. I have to say that, on Earth, no place exists in a vacuum except Earth itself exists in a vacuum of space. But if you're looking at Ireland, the potato famine of the 1840s was exacerbated by England. England was not, could have assisted Ireland, but they were not due to political reasons. So it could have been mitigated to some extent, but it wasn't. But I mean, the point is still the population was artificially increased in Ireland due to the potato. And once the potato was no longer able to produce, the carrying capacity of the island was reduced, and the population of the island fell dramatically as over 1 million people died and 1.5 million people immigrated. So another example of carrying capacity is the island of Rapa Nui, also known as Easter Island. It's an island that you might recognize from these statue called the Moai. So it's an isolated Pacific island with very poor soil and little water. It was settled by a handful, 25 to 50 Polynesians in the 5th century. And these people here, they survived easily on chickens and yams, and they had enough food that they had plenty of free time for leisure and culture. Out of this culture, they developed an elaborate competition between clans with the Moai, these statues. So different clans would make these statues, and the more statues you can make, the bigger statues you make, better. And so the civilization in Rapa Nui, it peaked in the year 1550 with a population of approximately 7,000. Then in 1722, a Dutch ship reached the island, and they found about 22,000 people living in caves. There was a primitive society that was in a state of constant warfare. So how did Rapa Nui go from a well-functioning, established civilization with around 7,000 people with a steady food supply that allowed for leisure and culture to 2,000 people living in very primitive society and constant warfare? Well, it's because the island's carrying capacity had been drastically decreased by the society's actions. So in order to transport these moai, these statues, they had to roll them on tree trunks. In order to do that, they had to cut down the trees. And as they cut down the trees, the roots from the trees were no longer there to prevent the topsoil from eroding. Whenever the topsoil eroded, they can no longer grow the yams. And they also did not have the trees to make canoes that made fishing difficult and escape impossible. So this is an interesting example where the actions of the people themselves on the island reduced the carrying capacity of the island, causing their civilization, as it was, to collapse, to degrade. Now, is this a small microcosm for our planet? Well, maybe, right? We live on a planet that is an island in space, just like the Polynesians lived on Rapa Nui, which was an island in the vast Pacific. Their actions of cutting down the trees to transport the moai changed how much food their island could produce, and therefore changed the number of people that could live on an island. Now, as we live on this planet and we alter this planet through all the different things that we do, through our waste, our pollution, through our emissions, greenhouse gases that cause the warming of the climate, we are altering the planet, and therefore we are potentially changing the carrying capacity. Now, I don't want to sound all doom and gloom. I'm not saying that society is going to collapse, but I'm saying that it is a possibility that in the future our actions could cause changes in the amount of resources available, and that could cause issues with providing for the people on the planet. We've already seen some instances recently where countries are concerned about their food security. For example, in India, in order to support their population growth, they have a genetically modified strain of rice that produces more grains of rice than the native species of rice. However, the genetically modified, more productive strains of rice are not as drought resistant as the native species, meaning they can't survive through prolonged periods of time without rain, as well as the native species. Well, as the climate is changing due to warming, the regions in India are experiencing more and more drought conditions. And so these genetically modified strains of rice that were serving the food needs, helping serve the food needs of the people of India, are now underperforming. And so that's causing a concern about food supplies. And we don't think about this often, at least most people don't think about, is that plants are sensitive, are very sensitive to temperatures and precipitation amounts. And as the climate warms, those the temperatures and change, and the amount of precipitation changes, and that can disrupt the amount of food we can grow in different regions. Some regions we might be able to grow more food, but in other regions we might grow less food. Also, the acidification of the ocean, a third of all the CO2 we emit dissolves into the ocean. Whenever carbon dioxide dissolves into water, it creates carbonic acid that makes the ocean more acidic. That's causing us having impact on marine life. And we have, in some parts of the world, we are overfishing fisheries, which means we're taking more fish out than are being reproduced, and so the populations are decreasing, and so we are threatening some of our fisheries throughout the planet. So with all these actions, we are potentially jeopardizing the carrying capacity of the planet. And as the population continues to grow, our situation becomes even more and more precarious, right? Because we need more and more food to support a larger population. And so the larger the population is, the more sensitive it is to even the slightest change in food production. And so Rapa Nui can serve as a very useful lesson to us, right? We live on an island in space. We cannot acquire resources from anywhere else besides our own planet. And so we must do what we can to live in harmony with this planet so that it can continue to provide what we need to support our population. And as that population grows, that becomes even more and more important. So a summary and review from this lecture. So what are some, if you can answer these questions, then you took the most important points from the lecture. What are some common natural disasters? What are great natural disasters? Where do most great natural disasters occur? How are natural disasters and the human population related? What specific factors influence the relationship between natural disasters and the human population? And what are the future prospects of the human population, and how do they relate to the occurrence and size of future natural disasters? So that concludes our first lecture. Thank you very much.